From Transport Topics in Washington, D.C., this is Road Signs. Here is your host, Seth Clevenger.
Thank you for listening to Road Signs, the podcast series from Transport Topics that explores the trends and technologies that are shaping the future of trucking. In this episode, we're going to examine the potential for hydrogen fuel cell technology in the transportation industry. In recent years, truck makers and industry suppliers have been investing in a variety of cleaner fuels and zero-emission powertrains as shippers, carriers, and government regulators look for ways to reduce carbon emissions in the supply chain. Hydrogen fuel cell trucks, which convert hydrogen into electricity to run an electric powertrain, have emerged as one of the more promising technology pathways to zero emissions. But how, where, and when can these vehicles fit into the freight transportation industry? We'll set out to answer that question in this episode. But before we begin, I'd like to invite you to keep up to date on this topic and other important industry issues by subscribing to Transport Topics at ttn.ws/ttsubscribe. You can also text TT Subscribe to 571-622-0001. And now, to learn more about the development of hydrogen fuel cell trucks, I'm excited to welcome Parker Meeks, CEO of Hyzon Motors. Thanks for joining us, Parker.
Thanks for having me.
So hydrogen fuel cell technology is one of the pathways to zero tailpipe emissions in trucking. So this technology has been introduced in passenger cars as well, but it hasn't really taken off in the automotive space. So why do you feel this is a good fit for heavy-duty commercial trucks?
Look, it's a great question and one that we deal with every day with the fleets that are thinking about which technology they need to drive forward in their lower carbon future. And it's pretty simple, actually. Hydrogen is the right answer where there's heavy duty vehicles that need to carry freight a long way, carry a lot of freight that long distance, and that need to stay on the road as much as possible. When you look at trucking, there's a few things that we think shape the optimal solution for fleets across the technology spectrum. The first is just the fact that trucking generally is a low margin business, right? So uptime for trucks, how much freight they can carry, all that really matters to the profitability of that truck. And in the end, while many fleets now have board level, ESG mandates and decarbonization goals, they in the end have to have a program that maintains the profitability down to the truck level. So fuel cell typically outperforms other true zero solutions like battery electric, where you've got trucks that need to carry a lot of weight. A typical Class 8 battery truck is between 3,000 and 6,000 pounds heavier than a fuel cell truck. That's real revenue. That's real margin. You take 6,000 pounds off a Class 8 truck, that could take all the margin off that truck, right? So that's a big issue for fleets that do max out to the 80 or 82,000 pound loads. And I'm proud to say that today, Hyzon has the lightest zero emission truck on the market in the U.S. based on what's available in the heavy duty space.
Yeah, that payload issue is certainly a huge component as we look at some of the new technologies and added weight, especially in battery electric, that really dependent on the type of freight you're hauling. That can be a big challenge.
I think weight's a big issue, but the charge time and infrastructure side of it is also, I think, even more of an issue that we've seen in the last 6 to 12 months. Right, these trucks need to charge or refuel, and while the grid appears to be accessible, available, and charging technology appears to be available, the realities of these fleets that we're working with who are trying both technologies is charge time is longer than it needs to be, and the future megawatt chargers aren't available. And even once those are available, if you're going to do back to base fleet decarbonization like food and beverage or drayage or point to point freight, those trucks refuel behind the fence today, and that's what is going to drive the decarbonization transition in trucking is back to base operations, where they're going to prefer putting chargers or hydrogen refueling behind their fence. Trying to put 10 to 20 megawatts of battery chargers behind a warehouse fence is nearly impossible in a lot of the country where we have density because the grid can't support it. Substations need to be rebuilt and expanded. Local distribution grid capacity need to be expanded. And many trucking fleets that have tried to buy 100, 200 BEV trucks are seeing timelines of 6+ years just to get chargers, along with the need to change their operations and how they refuel or recharge their trucks that typically today is a diesel truck coming behind the fence to refuel their trucks in a matter of an hour or so. So hydrogen provides advantages to all of that. We can put it in dispensing on the ground with mobile fuelers to start, and with install dispensing, as delivery scale, without that grid limitation, and with the refueling time that's expected to be 15 to 20 minutes.
Well, let's dive a little bit deeper into the business case and the economics, right? We've started to compare a little bit, battery electric versus fuel cell here, but of course, today the industry runs on diesel almost entirely, with a little bit of natural gas and some other alternatives here and there. But when you look at any sort of zero emission truck, fuel cell trucks are going to be more expensive than diesel models, certainly at the beginning. But they do enable you to get away from the volatility of diesel prices, the ups and downs, that the industry's become so accustomed to. And of course, there are a lot of government incentives out there that are available in a lot of places. So when you consider all those factors, what's it going to take for hydrogen fuel cell trucks to achieve cost parity with diesel in the years ahead?
Yeah, this is I think one of the most important factors for large fleets that are looking to confirm their interest in hydrogen and to start a journey on fuel cell trucks is, what is the pathway to get to diesel parity from a TCO basis, a total cost of ownership basis, without the need for subsidy, so we can really scale. And the good news is we're already at cost parity with diesel in many parts of the world today with the subsidy that's available. And that is an important point to make, that we actually achieved that with a truck price from Hyzon, where we actually have positive cash margin coming back to Hyzon in the large fleet trucks we delivered last year in the US, and that we expect to deliver this year as well, right? Meaning we already have a truck that returns cash to Hyzon at a price that can achieve TCO parity with diesel, assuming that the fuel was in the tank at $6 to $7 a kilogram in the US and roughly €8 a kilogram over in Europe. The fuel side is actually the hardest part of that equation today, and one that we struggle in California to find fuel at that price level, which we can talk more about later. But we're very confident in the pathway on fuel with the projects coming online, that will happen. And we're already at parity on OpEx, including fuel, in Australia today. What has to happen to make this all subsidy free, and that is our goal, to be clear, this is not a business that works if you're perpetually reliant upon subsidy, is a clear path from a Hyzon perspective, because we are centered in the fuel cell technology itself. That's Hyzon's core competitive moat. A 200 kilowatt single stack fuel cell system, we estimate it's roughly 25% lower cost to manufacture than two 100 to 150 kilowatt systems that competitors have to use, because they don't have a 200 kilowatt plus single stack system, along with the other efficiencies we built into the truck, such as using 350 bar pressured tanks instead of 700 bar, which are much more expensive. And in the future, using liquid hydrogen, which we've already demonstrated, our liquid on board truck, with range we're expecting up to 800 miles, which is a much less expensive approach, both in the future on the tanks on the truck and in the dispensing capex and cost to do liquid dispensing versus 700 bar. That all combined with scale efficiency, scale economies, as we in the whole industry scales up a supply chain, which is ready to scale, but not realizing those benefits today, not just in the fuel cell manufacturing scale up, driving costs down, but also in all the other componentry, right? The tanks, the batteries, the e-axles and power motors. And then finally, fuel efficiency. And the good news on fuel efficiency is today, in comparable use cases, truck for truck, we're seeing roughly the same fuel efficiency as diesel in most of the use cases that we operate in, which is a great start, but we expect it to get a lot better. We actually anticipate, based on our 200 kilowatt truck testing on the test track in the US, those early results show us fuel efficiency gains of up to 40% on the test track, which we think probably erodes a bit when you have real drivers and hills involved as we get to customer trials. But we still right now believe our fuel efficiency on the 200 kilowatt truck will be a 20% improvement versus diesel, which is a massive impact on TCO, because of the fact that half of the cost to a fleet or a truck driver over the course of that truck's life is fuel. So all that adds up to a picture where we believe in as short as 4 years, we can be scaled to over a thousand trucks a year, assuming our scale ups that we're driving with large fleets in our pipeline. Getting ten fleets at 100 trucks per fleet over a 3 to 4 step program. At 1,000 fuel cell systems and trucks a year, with the additional technology development and fuel efficiency gains, we actually project we will not need subsidy once we achieve that scale potential and that time frame on the truck side. So we think the end of the decade is certainly achievable, and it could be a few years before that we're at TCO parity as an industry without the need for subsidy, at least on the truck side.
Okay, so we're talking, potentially by the end of this decade, not something that's a far future situation.
That's right, and that's because, frankly, while fuel cell technology has been in development for decades, right? I mean, Hyzon alone has been developing our fuel cell technology for 20 years through legacy company developments. Um, in this use case, it's just now being optimized, and the supply chain is just now being scaled, right? And it's something that doesn't face some of the issues that battery technology faces, right, on an all battery truck with scarcity of materials and cost of materials and scarcity of supply chain. The most scarce material in a fuel cell is platinum, and that's, I think much easier for us to secure and scale, given it's a very low quantity, relatively speaking, in the fuel cell itself, and can be recovered at the end of life. So all this means that while diesel's been through, decades and decades of development, and we'll see improvements, but they'll be incremental. Fuel cell technology and the TCO and fuel efficiency, we expect to make significant gains over the coming years as we in the industry scale.
Yeah, for sure. And just zooming out a little bit to the big picture, and the reason why the trucking industry is, within recent years, I'd say the last handful of years really has become much more interested in zero emissions vehicles. And this is part of course, a shift in regulations, clean air regulators, especially in California, where we have the advanced clean trucks and advanced clean fleets rules, really pushing the industry to phase in zero emission vehicles. And zero emission vehicles basically means battery electric or hydrogen fuel cell, in this case. So regulations are a huge part of this. From your vantage point, how are these emission regulations shaping the deployment of zero emission technologies in trucking? And how, again, we talked about this a little bit before, but how can fleets evaluate those options and compare battery electric for a certain application versus hydrogen and fuel cell as those options become more important?
Right. Look, this is a very critical, topic for us that we stay very close to, obviously, with our fleet partners and our fuel and hydrogen ecosystem partners that we have to bring this whole solution to market together with. And the overall picture is quite positive in several parts of the world, including in the U.S. And I'll separate the question into two main components. Right. When you think about government support, there's subsidy availability, driving economics, and driving adoption, with a solution that has the opportunity to scale and to get off subsidy. And then there's, as you're saying, regulations and requirements that help sort of force the issue, right? And on the first, on subsidy, we're actually in a very good position. So in the U.S., we see a very clear three-phase approach to scaling hydrogen technology in trucks to start, with support from federal and state programs at significant scale. The first phase being what we're in right now with California, right? $400 million of heavy duty truck subsidy available today, which is not moving very quickly, which gets a bit to the battery electric versus fuel cell point. But that subsidy is available today between the general fund and the HVIP CARB program and the drayage dedicated fund, and that can do, a significant number of trucks today, over the next, 12 to 24 months as we all start to get going. That's of course for both hydrogen and battery trucks, but part of why it's slowed down in terms of funds flowing out, is the relative slowdown of battery trucks being acquired and utilizing that program. Back in 2021, when the funding opened for the HVIP, you know, 2 or 3 times a year, that funding would typically sell out in 20 minutes. literally 20 minutes. And now there's 400 million sitting there moving, but relatively slowly, in part, we think because fleets are using battery trucks and seeing that they just don't meet the use case as much as they thought that they would. And there's major limitations on infrastructure as well, slowing down adoption. So California, we think, persists, and that is real and very well funded. Second is ports, right? So the Zero Emission Port Equipment Fund within the Inflation Reduction Act, the IRA, that fund has $2.6 billion available for zero emission port equipment, which includes drayage trucks and fueling infrastructure on port property. And that's not just coastal ports, it's also inland ports. So we're quite excited about that program. The first grants are expected to be made in December of this year to ports, and we're supporting several ports in their applications of up to $500 million per port to transform and with drayage trucks and fueling as a part of the applications. For instance, we did the first trial of a fuel cell truck ever in the Port of Houston in Texas, which is one of the top 10 ports in the country with about 7,000 drayage trucks, to show that the technology is ready. And Texas, actually, in the triangle between Houston, Dallas, and San Antonio, is a tremendous use case with lots of fleet demand with the port subsidy that the Port of Houston, we hope, is able to secure, along with the DOE hydrogen hub that Houston was awarded, the high velocity hub. So that's the third phase, right? Is the DOE hubs, and that $7 billion we think is instrumental and foundational. And when you look at how this lays out, you've got California and then the 15 or so other states which signed on to the MOU to sort of follow California's success and lead. State level funding that we think in blue heavy states is rather secure to persist. You have the IRA port money coming behind that with awards starting into this year and hopefully money flowing as soon as 25 to then create these port-based hubs along the coast and some of the inland infrastructure. And then the DOE hubs, which provide a full ecosystem with trucking as part of 5 of the 7 hubs that sort of fill in other parts of the country that where the states may not move as fast. And in Europe, I won't go into as much detail, but generally, we see supportive subsidy at the EU level and several, nations like Germany and France and the UK that we're excited about the funding situation for that. On regulation, that is a bit of a different story in terms of there's a lot of uncertainty, even in California, as to exactly when those regulations will be enforced. We are here to support our fleet customers and to support them in meeting their goals, whether they're regulatory driven or internal, management and board driven. So we don't really comment on the regulations, and we're just here to provide a solution. But at the same time, we look forward to working with fleets, to help them meet the requirements, and we certainly see California as a critical proving ground to make sure that we all get this right. But the positive news for us and for the industry in general is even without the regulations, there are a number of large fleets who have board level mandates to drive adoption, right? And one example is our anchor customer in the U.S., Performance Food Group, or PFG. The fifth largest private fleet in the country with 7,000 trucks. They're a real leader in trying to drive impact in ESG. And they have a stated public goal of taking 20% of the diesel per case out of their fleet by, 2030. That's a real goal. That's a lot of trucks they're going to have to augment or replace. And so that's where we focus is on real large fleet leaders who want to drive decarbonization programs and where we can get them into, an adoption cycle that helps them achieve their goals.
Hello, Roadside listeners. Dan Ronan here from Transport Topics. I'm here to tell you about our new extended cuts of the Road Signs podcast. If you like what you learn here, I think you're going to really love this. So what is the Road Signs extended cut? Well, instead of ending the recording and saying our guest farewells, we're keeping our expert guests around for an extra 1 or 2 questions to gather a deeper, fuller picture of the influential topics in transportation. We capture that insight and convert it into a printable download that will help you navigate the latest trucking trends and guide your next business decision. Considering the easy, linkable, and printable format, You can keep the extended cut for your next big meeting, send it to your friends and colleagues, or pack it up for your next big conference. So, how do you get the latest download? Well, it's real simple. Visit ttn.ws/extended cut. That's ttn.ws/extended cut.
A question that I think always comes up is, what are the types of trucking applications that might be the best fit for this type of technology? And I'd say that for the past several years, hydrogen fuel cell has sometimes been presented or described as a range extender for electric trucks, right? I mean, keeping in mind the limitations, the range limitations of a battery electric, and the weight added to add the necessary battery to go longer distances, especially in a heavy duty trucking application. But what do you see, both I guess near term and longer term, the right use cases for fuel cell electric trucks in the future? Is this in terms of length of haul, the types of freight? You mentioned Performance Food Group, but what do you see as the types of trucks that are really a prime opportunity for hydrogen fuel cell?
Yeah, look, I think this is becoming more and more clear, and the theme is those use cases are expanding away from battery towards fuel cell. And first, just to say it, when we walk into a fleet and start working with the fleet on their decarbonization goals and where fuel cell can fit, we're not bashing battery electric, right? We believe all fleets will have both. It's all about finding the line on exactly what you're saying on load, on range, and on uptime. And what's interesting is we've seen that line move towards fuel cell pretty significantly as fleets get more into um, battery electric testing and seeing what range is real, particularly in cold weather. What the weight does to their economics, and what charging infrastructure is realistic, and how their operating system has to change to rotate trucks to charge overnight, for instance, which they're not used to doing. So, generally, if you'd asked me, a year ago, what percentage of Class 8 market do you think goes fuel cell versus battery electric in a full zero world? I would have said probably 60% fuel cell, given all the long haul, because there's a pretty stark line right now. Anything over 400 miles in a day, it's just really hard for battery to even approach that until there's significant improvements in battery technology, without really making um a weight penalty that is just too much for fleets to deal with. Um, but that line is moving much lower because of range limitations that we're seeing, and because of infrastructure challenges and costs on the charger side. So today we see fleets that anything down to 200, 250 miles, they're actually going away from battery, right? And that's even for fleets where these are not full loads. These are trucks that are packing out, meaning they're hauling bulky light stuff like shoes, right? That you would think would be a good fit for battery. They may be in a part of the country where there's a lot of hills, and when battery has to absorb itself up and down hills, even a 200-mile route can be a challenge. And when you look at places like the LA Basin, where a lot of the demand is today, if you go anywhere in the LA Basin more than 100 miles, you're probably climbing a hill. Really, we're seeing long term. We need to have a truck that can really compete with diesel, and that can go. We think above 600 miles, 700 miles. And that's why we were so proud of our liquid hydrogen truck demonstration with PFG in Texas. That was a real 16-hour day, 540 miles, fuel left in the tank, real operations with eight stops at customers. And we project that truck will go 800 miles once it's fully commercialized. So we think we have the answer long term to compete with diesel. And with battery, even our truck today, which is about a 350 mile, range truck in most applications, we're competing for a significant portion of the route tree, where BEV just can't deliver, based mainly on real range across all weather conditions. And if you ask me the question now, what do I think the total Class 8 market becomes in a true zero world? I think that number is probably 70-75% fuel cell.
Okay, well, it's very interesting to see, how the technology will develop in the years ahead, and as fleets start to look at this on a application by application basis, and what are the right options for their specific operations and specific routes, and yeah, I think the answer, of course, varies depending on the type of freight and the range needed, and uh, even the region of the country and the conditions you're operating in. But uh, one of the issues that you've been touching on, of course, is infrastructure, and that's I think an issue for any alternative fuel or electric vehicle, anything that's not diesel, where we already have a built out national fueling network. For battery electric, of course, there's a lot of challenges that the industry's run into in terms of working with utilities. That seems to be probably the biggest hurdle right now. Is lining up making sure that there's access to the and support for the power demands needed in certain markets, and the wait time sometimes it takes to get a new charging depot up and running. But there's also the same similar fueling infrastructure question for hydrogen as well, right? There will need to be a build out of hydrogen fueling infrastructure to support fuel cell vehicles. So how are you approaching that issue at Hyzon and getting that network in place, to support these vehicles that you see entering the market?
Look, this is literally the bottleneck today that we're working through with our fuel partners and with our fleets to get the decarbonization program started for many of these large fleets. And I've said publicly a few times that if we had better solutions for fuel today, at Hyzon, we have completed, 18 major fleet trials in North America last year. A number of those fleets are convinced that fuel cell is the way to go, and we're at, we know exactly how many trucks we want to put to work together over a scale up program, where they should go, et cetera. And the fuel is the last piece that we're finalizing and confirming with them a feasible pathway on fuel that allows them to have the confidence to enter into a multi-year agreement to scale up trucks. And multiple of those would be done by now if we had a better answer on fuel today. And the good news is the answers are out there, right? The solutions are out there from a hydrogen fuel infrastructure perspective. And it should come faster than battery electric due to the multi-year delays that we're now seeing with battery chargers due to grid restrictions. And the answers look like the following. So, if a fleet is excited to start their decarbonization of the fleet through fuel cell, and they're going to commit to 50 or 100 trucks over 3 or 4 years, it's always going to start with 2 to 5 trucks in the first year, right? These fleets, and we as well, want to start with a small number of trucks that we in their operation can put into place that are easy to fuel, that are easy to service and maintain. They're easy for their service providers to train up on, and to get into this in the first year, really getting the experience with a meaningful number of trucks, but a nice first step. And then to scale that to, call it 15 to 30 in the second year and call it 30 to 50 in the third year, et cetera, right? As we're scaling across probably multiple warehouse facilities. The fueling mirrors that. So it's mobile fuelers today. So think of it as like a gaseous trailer that holds between 500 kilos and a ton of hydrogen on site with a dispenser, where they're able to dispense and fuel up to typically 20 to 30 trucks if it's a 1-ton trailer a day, with an operation that's pretty similar to how they do diesel today, right? Which is on site with a diesel truck, right? And those trailers can be dropped and swapped every day, and there's providers for that. Now that is expensive, right? It's not $6 a kilo. I'll say that. But the good news is, like, fleets don't need $6 a kilo today to get going, right? These ESG leaders, and both private fleets that are doing it for their own benefit, or for hire fleets that are doing it for their end customers' goals, right? Want to get going, and they want to start to see an impact, and they want to learn, so that as they see the fuel cost coming down, which that's the key thing that we have to lock in, right? That we're getting to $6 to $7 a kilo post subsidy in the tank by 2026 or 2027. So, like tactically, the vision is pretty clear. The fuel price environment and the infrastructure that we expect to put in place with our customers, we think has a very clear pathway to get to that $6 to $7 a kilo by 26 or 27, with on-premise dispensing and maybe semi-private dispensing, warehouse-based. And what we're solving right now is getting, the first 2 to 5 trucks fueled at a price that is, not 6, but doesn't need to be much lower than probably 15. And that is also feasible and something we can solve. So this all takes partnerships, right? And at Hyzon, we focus on the fuel cell and the truck today. With our partners, we bring fuel providers in that can provide these end-to-end solutions, and There's lots of big companies and big balance sheets that I think you've seen that we're very excited about some of the announcements that are out there. Chevron making steps, Air Liquide and Trillium teaming up. Many others that are eager to provide fuel. That we just have to find the right structures to get these fleets going.
Yeah, and then switching back to the vehicle itself, let's talk a little bit about how Hyzon is commercializing this technology, right? So your company uses existing vehicle platforms and upfits them with your fuel cell system and powertrain. So just tell us a little bit more about your commercialization strategy at Hyzon and how you're bringing the technology to market.
Yeah, and I'd love to clarify that because given our name is Hyzon Motors, people think that we're a truck company, and while we certainly are, developing and deploying high quality, fuel cell trucks today, the core of Hyzon is the fuel cell technology. So the business model, as you said, is really focused on how do we move this technology out into major fleets' hands and build a backlog in a business that meets their goals, while only doing trucks as long as we need to, with a third party upfit model, having high quality, at scale upfitters that do this every day to scale the output of our trucks. And we work with Fontaine Modification here in the US, who is very respected in the trucking industry of doing exactly this with various technology to the tune of 50, 60,000 trucks and trailers a year across 11 facilities in the US. And Charlotte, North Carolina, in their facility is where we're scaling production of our fuel cell trucks with them. In Europe, we have a third party assembly partner that we're now working with to really do the same thing. Australia, today we're doing trucks in house with a similar vision to have third party take over as we scale. And this all is leading to a place where my goal is to hand 1,000 truck business to an OEM. Right. That's where we want to be, which, there are OEMs that we obviously are in touch with that see what we're doing, that we know what it takes to be that, tier one supplier and partner, and what level of a business scale is interesting to, someone who does a lot of trucks. So it's very clear to us what we have to achieve with our customers to build a business that is big enough that makes sense for us to be able to step back and be a fuel cell powertrain supplier. And that also allows us to expand the technology into the next ecosystems. And those ecosystems are things like stationary and remote power, right? Where we have our joint development agreement in place with Schlumberger, right? And there's lots of use case like data centers and hospitals and schools and remote industrial operations like, ironically enough, oil and gas drilling, uh, that use a lot of diesel generator power today. That a 1 megawatt mobile and or stationary, fuel cell in a box makes a lot of sense, and that's where Hyzon's technology is advantage. The fact that we have a single unit that does 200 kilowatts in net power in a single stack, when others have to do 100 or 80 kilowatt fuel cell systems. If you're using 10 modules to get to 2 megawatts of power versus using 40 modules, right, or 30 modules, it's just not scalable, right? So there's many others like ground support equipment for aviation, locomotives that we're excited about, that we have either early or advanced engagement with third parties that would scale our technology, assuming the development pathway is opened up. And we look forward to expanding our technology outside of trucks once the trucking ecosystem is fully commercialized and handed over to an OEM, which we don't think is too far out in the future.
Hey, Road Signs listeners. It's your man, Mike Freeze, here to tell you that the call-in lines are open. What does that mean, you may ask? Isn't this a podcast, not a radio show? You're correct, but we found a new way that you can call in and leave myself or my co-host, Seth Clevenger, a message. Leave us a message on new topics you'd like to hear more about, or ask questions you may have about the trucking industry. Give us a ring at ttn.ws/speakpipe.
It's all very helpful and add some clarity to how you're again coming to market. And it was about a year and a half ago. I was actually able to experience a ride along in a Hyzon truck. This was in San Diego at ATA's 2022 Management Conference and Exhibition, and riding along. And I remember it was through downtown San Diego, and What I recall is a smooth, quiet ride, but overall, not really that different of an experience from what you see and feel in the cab of a diesel truck. So, really, how do you envision professional drivers reacting to fuel cell trucks as they start to become more widely available in the market? Because, of course, driver acceptance and driver response to the vehicles is a very important issue for fleet operators.
Well, this is one of the most fun parts of my job, is when our truck is out on trial or in ride along or in commercial operation, having these 20, 30 plus year Hall of Fame truck drivers, and I mean that we've had the honor of having Hall of Fame truck drivers drive our truck, get in the truck, and they just love it. Right? It's quiet. They can talk in the truck to a passenger and actually hear each other. It's the lack of diesel, fumes and coming home smelling like a diesel rag. And it's the torque and the power that the electric drivetrain provides, giving them a safer experience as well. Because the most dangerous time for a truck driver and for the motorist community at large is when a fully loaded semi truck is trying to get up to speed entering a freeway. And when you're in an electric drivetrain, that acceleration factor allows them to merge much more seamlessly and more safely. So the reaction is strong. It's positive. They're excited about it. The questions we get, are around maintenance and service and functionality, and that's why part of our strategy has been to upfit into existing, OEM equipment that they already know and trust. So when they get in our truck, they've been in our truck before. It just hasn't had a fuel cell in it, right? And the way that we service the truck through the existing, service provider networks that they already use, where we just subcontract in our techs on the fuel cell and high voltage side to train as long as it's needed. Again, it's an experience that the truck drivers used to, and that the fleet's used to, with a truck they're generally familiar with, just with incredibly improved performance, right? So we have drivers that we actually had some fun experiences where the trial's over, we're ready to collect the truck, and the driver team lead comes in that day for his shift and goes, "Hey, do you mind if I take that truck out one more day?" Because they love the truck so much.
And another topic I want to bring up is just sort of this emerging competitive space for fuel cell. I mean, obviously, this is still very early days, very early deployments, and still a lot of R&D and an early investment. Uh, but it is something of a crowded field. I mean, Hyzon's not the only company pursuing this technology. Nikola, startup that's introducing hydrogen fuel cell trucks as well, working with suppliers like Bosch. Daimler and Volvo, of course, are big competitors in the Class 8 market, but they are working together through their cell-centric joint venture on fuel cell technology. PACCAR, the parent of Kenworth and Peterbilt, is planning to deploy trucks with fuel cell technology from Toyota. So there's really overall across the commercial vehicle market a pretty significant push toward this technology with a lot of investment behind it. On one hand, yeah, yes, that points to a lot of competition in the space in the years ahead, but also some pretty broad agreement that hydrogen fuel cell vehicles will be part of trucking's future. So, Parker, when you survey this landscape, what are your takeaways? Do you see this becoming a highly competitive segment of the commercial vehicle market in the future?
Yeah, so I think first of all, what's great from our perspective is the market opportunity here is significant. And it's so significant that many players can succeed with plenty of opportunity to scale, even companies like us that don't need the volumes necessarily of some of the large OEMs to make this business be exciting or to be cash break even. And to still have the big OEMs come in, and that landscape I think also will evolve, right? Like I said before, our goal is not to be a truck maker in the end. It's to be a tier one fuel cell powertrain provider. So many of the names you mentioned are names that we see as potential future partners that we're suppliers to. But we think the market is significant, and there's opportunity for many to succeed. It will be competitive, but time frame is also important. So there were only two truck makers that commercially deployed trucks to customers last year in the U.S., us and Nikola. We're excited to be a part of that early mover set. There's others that are in the market with grant funding demonstrations or plans to bring trucks to market. But when you look at where they are, right, across many of the names you mentioned, and some others, the time frames appear to be extending out, and that's simple. We think for a lot of the big established OEMs, they have profitable businesses to run where they're going to need to supply diesel trucks for a long time at significant levels, and they're also have other technologies that they're bringing to market, battery electric, CNG in some cases, and hydrogen combustion as well, right? So fuel cell is something that many of the names you've mentioned have said will come, but they're not in a huge hurry. And we think that we and other early movers have, 2, 3, 4 year time frame where there's really not going to be much traditional OEM commercialization activity of actually delivering trucks to customers and trying to scale. So our view is simple. We just succeed in our goals for 24 and 25 and in launching decarbonization initiatives with major fleets. We get them into the multi-year agreements through their procurement cycles, um, and set up the scaling, and then deliver high quality fuel cell trucks to advance that from the first delivery to the second year delivery to the third year delivery. Now you're embedded in a fleet's decarbonization program with a solution that's working, with fueling that's working, with confidence. And again, by that time, we're hopeful to be handing that over to an OEM to take it forward from there. So our success is led by the customer, and if we just achieve our goals, we feel very comfortable that both the market is significant and that we're early enough that we'll be able to create a business for an OEM to benefit from.
Yeah, and another question I wanted to bring up here is that the the natural progression that hydrogen fuel cell technology will make, the technology improvements over time. As you mentioned, diesel, of course, is very well established and has been refined and improved. The diesel engine has been improved for many decades, and we're at an earlier stage of development for some of these new technologies like fuel cell. So just maybe your insights on and thoughts on how hydrogen fuel cell technology could advance and improve in the coming years.
Yeah, I think there's significant opportunity for fuel cell technology and the fuel cell powertrain and mobility to improve. I mean, I gave some of the facts previously, but starting with our 200 kilowatt single stack fuel cell system, that's 25% lower cost to manufacture than two 110 kilowatt fuel cell systems, which we've made that leap. Others, are working to catch up. That's a material, reduction in cost per kilowatt, for the fuel cell powertrain. Additionally, fuel efficiency, right? So I talked about before, we're already seeing better fuel efficiency than diesel on our test track today in the 200 kilowatt fuel cell truck. And that fuel efficiency, by the way, is with a traditional axle on the truck, not an e-axle. Which once the e-axle is on the truck, which we're currently anticipating 2025 generation to have the e-axle on, that should provide additional fuel efficiency gain, right? And that's for the truck application. All we think we need is a 200 kilowatt with the right battery combination to give all the power and range that a truck needs. We are also, have talked about our future 300 kilowatt single stack fuel cell, which we already have in concept stage, and we'll start working on development of that in earnest once our 200 kilowatt fuel cell system achieves its start of production commercially in Chicago later this year. And that technology advancement and the ones beyond that really drive the other ecosystems that need higher power, like stationary and remote power, like locomotives, like heavy off-road equipment and mining. That 300 kilowatt building block, now you're into a building block that is scalable, right? That if you're trying to get to a megawatt, it's 3 to 4 blocks instead of 10, right? So it's going to be scale, it's going to be cost efficiency, scale efficiencies, it's going to be fuel efficiency, and as with that, also durability, right? So we do, currently project and expect a goal of 800,000 mile durability for the fuel cell in the trucking application. We're proving that, right? So that's all in our testing and durability process with our SOP. That's also what's advantage for Hyzon about being ahead, right? So by the time others achieve a 200 kilowatt single stack system, we may be 2 years down the line in improving durability and cost. So all this, we're excited about where fuel cell is going and where Hyzon is, and sort of leading the way.
Well, very good. I see we're running long on time here, but I'll I think pose one final question to you, Parker, and about the kind of the overall ecosystem of powertrain options and fuel options for trucking moving forward. Of course, today trucking runs almost entirely on diesel, but we're seeing all these different options beginning to enter the market. That includes battery electric and fuel cell trucks as well, but also combustion engines that'll run on renewable fuels. You mentioned hydrogen combustion as one of the pathways, and is distinct from hydrogen fuel cell. At the same time, diesel engines will continue to become more efficient to meet greenhouse gas and NOx emission standards. So you can imagine fleet operators in the future facing some pretty hard decisions about what powertrains and technologies are the right fit for their business when there's so many options potentially in the marketplace. So as you project forward, as you look ahead, do you see a place for all these technologies in the future, or do you anticipate a smaller number of winners of viable technologies taking hold?
Yeah, so look, I think that it will be a mix of technology, right? Because fleets are varied in their goals. We do think in the end we are headed towards a true zero world, right? And today at least, the only true zero solutions are battery electric and fuel cell, right? Hydrogen combustion does have NOx and SOx issues that if you control them, our understanding based on current technology has a performance impact on power, right? CNG can be a great step in reducing emissions versus diesel, but again, it's not a true zero solution. So in the end, we still think true zero is fuel cell and battery, and fuel cell is the majority and an increasing majority. However, in the transition, absolutely, you're going to see all these technologies, right? Certain fleets aren't as focused on true zero today, so they're willing to take a first step with CNG or with H2 combustion. Diesel will still be a big part of our fleet for a long time, right? So this is not an overnight change or even a 2030 change. I mean, even if we achieve our goals as an industry by 2030, I think we're only going to decarbonize like single digit percentages of the U.S. fleet, right? So look, we all have great ambition. It's all the right things for us to be doing. And the good news for us and for others in our space is there are there are major fleets, again, like our anchor customer PFG, that want to make an impact now, that want to get started, that believe in true zero, and there's plenty of that interest and real goal for us to scale this technology. We think relatively quickly in this decade. While we all need to take a customer backed view, right? That again, this is not about saying this is bad or that's bad, and this is better. It's about what works best for fleets and what achieves their goals. And there's plenty of opportunity for us to scale fuel cell technology with fleets that really want to go true zero faster.
So certainly a long road ahead with this shift in technology, and we're really still in the early miles. But this will be a fascinating time in the industry's history, really. And some of the early adopters that are out there now are helping to shape it. But Parker, this has been a great conversation. I think we're at a good stopping point here before we hit the hour mark at least. But thanks for joining the podcast and sharing your insights. I really appreciate your time and your thoughts.
Really enjoyed it, Seth. Thanks for having me, and I look forward to keeping the discussion going.
Absolutely.
Did you know you can ask Alexa to open Transport Topics? In just 1 minute, you will hear the biggest trucking headlines of that day. Be prepared and start your morning off right with Transport Topics.
Before we close, let's take a moment to revisit our original question. How, where, and when can hydrogen fuel cell trucks fit into the freight transportation industry? As we've heard during this episode, hydrogen fuel cell is one of the technologies that can make zero tailpipe emissions a reality in trucking. And that's especially important as government regulators and a growing number of large shippers with corporate sustainability goals take steps to reduce carbon emissions. But there are many hurdles to overcome, including the need to develop hydrogen fueling infrastructure to support these vehicles. And, like any other technology, fuel cell trucks ultimately will need to provide a return on investment for fleet operators to succeed in the marketplace. Despite these challenges, the significant investment in hydrogen fuel cell technology across the industry clearly highlights its potential for the commercial vehicles of the future. If you've enjoyed this episode of Road Signs, please let others know. Rate and review us on Apple Podcasts and Spotify. If my questions have sparked questions of your own, share them with me and the Road Signs team. You can email us at share@ttnews.com. We'll read them and respond daily. Also, let us know how we did by texting TT Survey to 571-622-0001. And of course, we'll be back soon with a fresh episode of Road Signs. Until then, I'm Seth Clevenger. Thank you for listening.